Seems like I am live on YouTube and refresh and upcoming shit. No, I am live on YouTube and on Twitch also. I am live. Shit, I am not unlive. I'm live on YouTube and I'm live on Twitch. Let's get going. Okay, so today we will be writing a Hello World program in assembly language. Right. Let me first remove everything that was here before and now create a new file hello.s. Right. First, I'll just write down the code that is required to print hello world to the standard output that is the terminal, and then I will try to explain how that works. Global main, okay? Align to, which is not really necessary, but we are just using it. And then here we go main. We are using main as a label here, and in the x1 we are moving a value in the x1 register, the value 1, and we will be loading a value in the x2 register. And what is the value? Value is the address that is stored in a label, and the label is hello. And we will be defining that label below the code. And then in the x3, shit, my bad, registers start from 1, 0. Now, yep. In the x2 register, we will be putting in the length of the string that you want to print, which is going to be 13. We can do this manually, or there is another way, but uh, we will do it. We are going to do it like this for now. And then, yep, the syscall number is going to go in the 16th register, and the syscall number is 4. And then we are going to call the syscall, and this will print hello world to the screen. And then we are going to call syscall number 1, which is exit. And then we are going to call it the syscall. And now we are going to define the hello level, which will store as keys value, and the value is hello world. And this should work. And see, we are defining the hello world memory in the text section of the memory. Right? Keep that in mind. That was a big problem yesterday. And now we are going to compile it using the GNU-C compiler, hello.s, and the output file would be named hello. No issues. Shit, I was afraid. And then /hello, and we see nothing. Shit. Ah, okay. Uh, things seem to be right. 4 is for right. As I remember correctly, 4 is for right. And we have to store in the 16th register. And then we are exiting perfectly as it should. And we even have the, oh, maybe, how about ADR? I think that will work. Let's see, compile it again. No problems in compiling. And hello, we got hello world. Right. Uh, we got this weird symbol at the end because we are not using \n at the end. We can do this, or let's try something else. We can either do this or we can do this. ASCII 0, 0. Well, no, I guess it is A. A stands for 10, and 10 is the ASCII code for a null character. Right, let's see if this works. It should, I guess. Um, GCC compile, and it does not work. Why? I expected a string. Yeah, because I'm storing a string, not byte. Okay, and hello dot. Well, I can store a byte. Let's see if this works. This does not work. Why LD relocation admin is not supported under address something something. Linker command failed. So we are able to make the object file, but they are not being linked properly. Okay, let's just use the ASCII's command here and put the new line character here inside the string. And now compile it. This should work. And now it should, after printing hello world, this should go to the next line, and that it does. Now, let me try and explain what these mean. Alright, dot global, this is a directive. Dot, dot global, this is a directive which is used to specify that this thing, the label which comes after it, can be accessed from external functions. Functions can call this thing externally from the outside. And then dot line, but this is a lengthy thing, but dot align basically means that this directive dot align is used to store data in the memory at specific end blocks. Okay, you can think about that memory consists of a lot of tiny cells which are 1 byte long, and you can store data in those. And then you have data like an integer which takes 4 bytes, that is four of these cells. Then you have data like a single ASCII character which takes 1 byte to be stored. And then you have a whole string, you might have a whole string which which can take a lot of byte depending on the length of the string. And now let's say you stored uh, let's say you stored something like uh, a number. This is just a name. We can call this anything. A number which takes 1 byte, and the number is 1, right? So uh, let's say you started at byte number 0. The address of the byte is 0. Now you should be, this should be, should indicate that this thing is stored at address x, ah, x, 0x 0. That was the problem before. Okay, so now we know that this number thing is stored at 0th byte. Now let's say you store another number, right? And that also takes a byte, and that, let's say, number is this, and we know that the first number was stored at the 0th address. And then after storing it, our program location address pointer moved to the next cell, and which would be at the next address, and which is 1. And now let's say instead of a number which takes 1 byte, shit, a number actually takes 4 bytes, an integer, but we are storing it in a single byte, right? So now let's say now you have to store something that is bigger than a number. You want to store a big number, and this big number takes a whole word. And how do you specify that you want Let's say that this number takes 4 bytes to be stored. That is, 4 bytes is a word, is called a word, and then you stores a number there. Then the address for this big number will contain will be the first address of the 4 bytes which are used to store that number. And the first address is this, because the last byte that we stored was at the one address. And now, let's say you want to store another big number, or let's say just a small number 2, number 3, something, and that only takes a byte. And you store that number. Where will that number go? That will go to at the second address we stored. We started storing this big number at starting at the second address. So the big number took the second address, the third address, the fourth address, the fifth address. Three things, 3 bytes. And now, since we have stored our data in 4 bytes, 4 consecutive bytes, uh, till fifth byte, starting from the second till the fifth byte. Therefore, the next thing that we store will be at the sixth byte, sixth cell, right? So that is how data is stored. Now, what does this align thing does? This align, um, let's forget about the number. Let's focus on the align, the functionality of align. The way that memory RAM is made, it is easier if I want to fetch a number, some data which takes 4 bytes. If I want to fetch a data which is 4 bytes long, then it is easier for the memory to fetch it if it is at a boundary of 4 bytes. What do I mean by boundary of 4 bytes? Start. This is the memory address, right? And then these are memory addresses. Okay, so um, yep, these are memory addresses, and RAM has like lot of these, and millions of these, right? Memory addresses. And if I want to get a value which takes, let's say, 4 bytes to be stored, then it would be faster for the RAM to fetch them if those 4 bytes occur at a boundary of 4 bytes. That is, like right now, it is not at the boundary, because these first 4 byte make like a one 4 byte cell, and the next 4 byte make one 4 byte cell. So it would be easier for the RAM to fetch them if they are at a place like this. But if my 4 byte value is not at a memory, at a boundary of 4 bytes, then it would be harder. RAM would take slightly longer to get that value onto the processor. So what this line thing does is, let's say I stored the first number here, then the number one, which is 123 here, and then I stored a big number which took 4 bytes, 2, 3, 4. And now I see that this is not at a boundary of 4 bytes. Therefore, I would like to start storing the big number starting from here. So what do I want is I want to skip the second and the third byte, the second and the third memory cell. How can I do that? That is done by a line. Whenever there is this align function keeps whenever the assembler sees this align function, this align derivative, this align delimiter, declarative, this align thing, then it sees that if the program counter, which keeps the memory address for the current location in memory where the next thing should be stored, if the assembler sees that the program counter is not at a boundary which is specified by this number here, then the align function moves the pointer enough memory cells so that the mm, uh, program counter is not the program, the location address, the location is at a boundary, is at a boundary cell which is specified by this number. And this number does not mean that I want the boundary to be after every two memory cells. This is this is taken in as a power of two. That is two. If I say two, that would actually mean 2 power 2, which is 4. And if I say 3, that would actually mean 2 power 3, which is equal to 8. So here, by saying 2, I am specifying that I want my location counter to be at a boundary of 4 bytes, right? So when this moves the location counter by 1 byte, this moves the location counter by 1 byte. So when my assembler sees this align thing here, then it sees that the location counter is here, right? So it is not at a boundary of 4 cells. Therefore, it moves the location counter 2 bytes and starts storing the big number here so that I can fetch it faster. That, I guess, makes sense. Now, what does this text mean? Text means that the memory, the part of RAM that a program gets, is divided into 6 things. First, there is the stack. Below the stack, there is some empty space so that the stack can grow and go up, and the stack grows downwards, right? And then some empty space. Then there is the heap. Okay, they have their own functions. And then there is, what is there? There is something called BSS section of the memory. Then there is RO data section of the memory. Then there is data section of the memory. And then there is the text section of the memory. So whenever you use what is this thing called declarative delimiter or something shit? How can I be so stupid to forget this? This was like in the first chap, in the second chapter, the whole thing. Um, Directive, too stupid. Yes, this is called a directive. So whenever the assembler sees a directive, whatever comes next will be stored in that part of the memory, right? If I want to store something in the stack part, I write dot stack, and well, for a stack and heap it is different. But if I want to store something in these 4 parts, I can just write dot pss dot ro data dot da dot data dot text to store things in that. And what is the function of these things? Stack is used to keep track of things that require ordering, like recursive function calling or something like that, like call stack in JavaScript. And then we have heap. Heap is used to store object data, data that heap is used to get memory that is allocated at the time of the program execution. Then we have the BSS section. BSS section stands for block started by symbol. It means it is used to get memory for variables which have only been initialized, which have only been declared but not have been initialized. .ro, read only data, data that cannot be changed but can only be read. For example, const values. Then we have the data. It is for the variables that have been declared and have been initialized. For example, in C, int a equals 69. And then we have the text section, which stores in the actual instructions which will run. Therefore, before defining the instructions, we are using dot text section. Hmm. We are using the dot text declarative. By writing dot text here, we are saying that whatever comes next should be stored in the dot text section of the memory for this program. And now we are using this label. Label is just a variable which stores address of the thing that comes after it. So this main label, I can use it to refer to the memory address where this first instruction is called. And at the time of compilation, my compiler will look for the main function, main label, and it will make the program counter go to this first instruction in the uh, main label, and then therefore my program will start from this thing, from this instruction, and then move all the way. And now we are storing this variable hello label here. Hello is a label which stores the address of the first character, this H, and we are storing it in the text section. Here, we are not storing it in the data section, we are storing it in the text section, and there is a reason for it because dot, the instruction that we are using here, ADR, to get the address that is stored in the hello variable into the first register. It only works for the memory for the addresses that are in the current section of the memory, that are in the same section of the memory as the instruction. So if it were in the data section, then there would be a different way for me to get the address for that thing in a register. But now this is what it is. So, right, I have data, all these things, and now I want to print something. And what does this mean, right? So to print something on the screen, that is something too complex for the processor to do. Processor is easy. Uh, it is easy to make processor do some simple arithmetic like addition, subtraction, and maybe a little more complex like branching to some other instruction address. But to make the processor print something to the screen, that is very complex, and that is handled by the operating system, the operating system kernel. So we have to tell the operating system that we want to print something to the screen, to the standard output. The standard output is the standard place where by default something that we want to print goes, and that is the terminal by default, right? So these things that uh, you want the operating system to do something for you, these things are called system calls, syscalls, and there are ways to call them. And for Mac OS, if you want the Mac OS operating system to do something for you, then it says that if you want it to print something, then it says that add the number 4 in the 16th register, right? Put the number 4 in the 16th register. Number 4 is the code for printing something to the output for writing something. And it says that put number 1 in the 0th register. What does 1 mean? 1 says that the thing that we want to write is the standard output. We want our thing to go into the standard output. And it says that in the first register, put the address of the first character in the memory that you want to print, right? That is what we are doing here. We are loading the address into the register 1 of the level hello. And then it says that in the second register, put the length of the string, right? And the length of the string is 13. And then to actually call the syscall, we use svc supervised call 0. And there could be 0 or 1. And this number could be 0 and 1 depending on something which I don't fully understand. But it is like there is some difference about who actually handles the syscall. If I put in 0, then maybe the kernel handles it, and if I put 1, then something else. I don't fully understand it, but this is how it is done. And then, and yes, simple things like this moving function, this ADR, loading the address, this move function, moving things to the register and adding and subtracting them. That is done by the processor. We are telling directly the processor to do these things. But here we are getting out of the processor mode and we are accessing the thing which the operating system uses. The kernel is uh, comes with the operating system. Every operating system has its own kernel, and here we are accessing the kernel. We are coming out of the processor mode and going into the kernel mode to do a syscall, right? So at this point, our thing hello world is printed to the standard output, and then we move number 1 into the 16th register. And remember that 16th register stores the number for the syscall that we want to call. And we are putting number 1 here in the 16th register, which and number 1 is the syscall number for exit when we want to exit the process, and then we call that syscall using svc supervisor call. And after that, our program ends and we are happy ever after. And now the compilation process. GCC hello.s. We compile and then we press run and we see hello world. How long did it take me? I guess 15 to 20 minutes to explain it. How long did it take me? YouTube is lagging a bunch. And yeah, it is not very beautiful. All right. And now what we are going to do today. And see this man, George Hotz, right? Hotz, HOTZ. He's a hacker, the first person to ever jailbreak an iPhone, and he did that in 2017 when he was less than 20 years old, I guess. Yeah, enough. Yes. For today, we are going to solve some assembly language problems. Everything is a stream, right? Let's ask ChatGPT for give me basic assembly language, beginner assembly language problems to write code for. Uh, let's see how far we get. Add two numbers, we can do that. Multiply two numbers, we can do that. Subtract two numbers, we can do that. Swap two variables, we got this. Store and load. Create a program that stores a value in memory and then retrieves it back into a register. Okay. Yep. Find the maximum of two numbers. Control flow loop and add. Okay. Let's start. Write a program that takes two integers as input and outputs their sum. That takes. But where is it taking the two integers from? Okay. And outputs their sum. So there are two ways. Uh, well, broadly, there are two things that the function can take input from. Like, let's say this is my sum function, and I can type the input here, right? Or I can call the function another from a C program that calls the assembly function and gives the input to the assembly function to add two numbers. Okay, let's see how we can give input right here. And I think I might be wrong, but let's see. Some dot s uh, dot global main dot align for aligning at four spaces. Then in the dot text section, I define the main label. And when a function takes in input, the first thing is when a function takes input, the parameters it takes start from register 0 and forward. So uh, my inputs will be in a register 0 and in register 1. So I have to just add the things in these. So I will just use the add instruction and store the output in the 0 register, right? What are the things that I want to add? The contents of the 0 register and the contents of the first register. Now I have added the thing and now I want to print the thing. And for printing, I have to store the thing in the memory, right? So I would like to have something in the memory section, like something called number, which will store a byte. And what will the byte be? Let's say it is 0 at the time. And then I can, hmm, how can I, yeah, store the value that is at this, where to the address that is stored in the number. So I guess maybe I should get the address, load the address first, load the address in the first register of what? The number variable, right? And then store what the value that is at the 0th register, where store it in whatever is the address at the first register. Now in the first register, I have the answer. In the no in the number address in the memory, I have the answer. Now to print it in the first register, I have to put in the first register, I have to put in the value 1, which specifies that I want to print to write to the standard output. And in the first register, I already already have the address of the memory location that I want to print. And in the second register X2, I have to put the length of the thing that I want to print. And then in the 16th register, I have to put in the code for writing. And now SVC 0 to call the supervisor call, and then to exit the program, I have to put in the 16th register the value 1, code 1, that is for exiting, and then call the thing. This might be pretty wrong. I think this will not work because in that byte, in the byte that I have in the memory to store the number, I am storing a number, but I want to print a string. So uh, when I call this is call, it will go to that memory location and it will see what is the number, and it will interpret that in as ASCII code for something, but it is not an ASCII code. It is just a pure number stored there. So that will result in a problem. So how can I? Well, but let's see. Apart from theorizing stuff, let's see. It works, and will the input go like this? Okay, bus error. Okay, bus error. Sum dot s. Okay, I am getting a bus error. What does it mean? Uh, it might mean that I have something in the 0th and the first register, but like I am calling the thing at the 0th and the first register, but I don't actually have anything there. So mm, let's ask ChatGPT how to give input to a assembly function at the time of calling it. When calling a function, you typically pass inputs through the general purpose registers. Use the procedure call standard PCS to define how arguments are passed to functions and how results are returned. Registers for arguments. The first eight arguments are passed through the register 0 to x. If there are more than 8, the additional arguments are passed on to the stack for a return value. The return of a function is in the register 0. Okay. Steps to pass inputs to a function. Load input values. Before calling the function, load the input values into appropriate registers 0 to x. Call the function. Use the BL branch with link instruction to call the function. Handle the result. After the function executes, the result will typically be in 0 register. Example, passing two inputs to a function. Yeah. Add number. This takes in two inputs. This is exactly what I did. Then return the main code. Main code is this. Okay, I put some number in the 0th register, then some number in the first register. Then I call the add BL add numbers function using the BL branch with link. And then the result will be stored in the 0th register. And then I will move number 83 into the 8th register for a standard exit call in Linux. And then SVC. Okay, now if I want to use more than 8 arguments, okay, how can I input when I uh, run the queue table like dot slash add and 1 and 5 to allow input to your ARM64 program when running it with arguments. At this, you can use the argv feature of the Linux call interface. These arguments are passed to your program via the stack during program execution. When your program starts, the arguments are passed via the stack. The number of arguments, including program name, is stored in the zeroth register appointed to the array of arguments. argv is stored in the first register. Each argument in the argv array is a pointer to a null terminated string. Okay, null terminated string. Okay, you need to parse the string arguments to integers, perform desired computations. Okay, how can I parse in a similar language? That would be a good thing. Add dot s start. Read the arguments. Move argv pointer to the X register. Okay, then load whatever is in the first argv pointed to the first argument string. Okay, and then this means the second argument is string. Load the address for that, and for that, okay, convert arguments from strings to numbers. Okay, BLATOI convert in integers, ASCII to integers, convert argv1 to integer, result in x. Okay, so whatever is uh, convert argv1 to integer. Okay, result. Okay, okay, result will be in the first register. First register. Now move whatever is the value in the first zeroth register into the fifth register. The first number is now there. Now move whatever is the value in the fourth pointer, which is the second number pointer to the second number in the first register, and then BLATOI ASCII to integer. Now convert that, and the result will be in the second zeroth register. Now then move the result in the sixth register. Perform addition. Store in the second register the summation of the fifth and the sixth register. Print the result. Move uh, ATOI is a whole goddamn function here. Okay, print digit. That is a pretty long thing to do. Okay, function ATOI convert a string to integer. Okay, uh, this thing prints, this thing adds, and exit program. Move the exit code there, move the exit code here, exit syscall number here, move the exit code in the zeroth register, and then call the syscall function ATOI convert string to integer. Move whatever is in one register, move the value 0 in the one register will have the result. Okay, ATOI loop. Okay, LDRB load next byte from string the address that is stored in the zeroth register. One, what does one mean? W2, compare 0 with that. Check if character is valid digit. If it is 0, then go to the end, call the end thing. And if not, then compare what is in W2 with 9. And I think we should first start by calling the function from a C program that would be something. Yeah. Okay. Okay. We can remove this. All we have to do is add the thing here and then return. We will have the first argument in the zeroth register and the second argument in the first register when the C function calls this. And just do this. Now I have to write a C function. Sum dot C, no, sum dot C, which will um include stdio dot h and then int main. It will store the answer some value in the sum value variable. And how will it get the value? It will get the value by calling the summation function. Ah, where is the summation function? Sum dot s. But I think we should not call it mean. We should give it a proper name like sum finder. That sounds cool. Uh, right, sum finder here, and then declare the function, not define but declare that there is a function which returns an integer called sum finder, which takes in integer a and integer b. Now we are calling the sum finder function here with the number, let's say 5 and number 10, right? And then storing the result in a thing called some value, and then we want to print the result here. Um, the result will be a digit that will end a new line, and the digit that we want to print is the some value. And now we have to make the object files for both of these, right? GCC C for object file. Whose object file? Sum dot s object file, and the output should be some sm.o object file for the assembly code. And then GCC, we want to make the object file some dot c, and the object file will be named some c.o, right? And now we want to link these. How can I link? What is W? LD help, shit. For information. Oh, man LD. Manual for the LD. Here's the thing is that I want to link. Let's see how to read the manual description. Synopsis, files, and then options, and then dash o hyphen o to name the output file. Okay, it takes in object files. The LD command combines several object files in and libraries. It resolves interfaces and produces an output file. LD can produce a final linked image executable, dilib, or bundle, or with the R hyphen R option produce another object file. Okay, if the hyphen O option is not used, the output file produced is named A.O universal. The linker accepts universal multi-archive architecture input files, but always creates a thin single architecture standard Mac Mach oh, output file. The architecture for the output file is specified using the Arch option. Okay, Arch means architecture. If the option is not used, LD attempts to determine the output architecture by examining the object files in command line order. The first thin architecture, okay, layout and libraries. Okay, a static library, aka static archive, is a collection of .o files with a table of contents that links the global symbol in the .o file. LD will not pull a .o file out of a static library if needed to resolve some. LD will only pull .o file out of a static library if needed to resolve some symbol reference. Unlike traditional linkers, LD will continually search a static library while linking. There is no need to specify a static library multiple times on the command line. That is good. So I can just use LD for some assembly.o and some c.o, and the output file would be some. Let's see if it works. And undefined symbols. Printf referenced from main in some O. Okay, not found for architecture. ARM64. Okay, how do I define that? Arch ARM64. Oh, okay. How do I tell how do I input the standard library to LD function? Linking a object file in C with LD. CLD, LC or object files. LC, what is the LC command? Meaning of L, the L flag tells the linker to search for a library file named lib filename.a. Okay, and so on. Let's use the LC command. We can see it there, right? We have LX, where is the L command singularly without anything else. Is there not a way to find library, 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 library. Ah, library. Looking for an option to add a library. Let's just use the command ldl and r due to some reason c, sorry, and then arch arm64 to specify the computer architecture, then some assembly, the file that we want to link, and the output would be named some. Library C not found. Arch ARM64, some assembly.o, some C.o, and o some. Library not found for L. Okay, so after L comes the name of the library. This command will link your object file with the C standard library libc to create an executable named our program. Special libraries like math, standard C library. Yep. That is what I want. GCC main printf. I want to add to link the printf function. The only correct way to link a superspace C binary is by using the appropriate compiler front end. Is never correct. Oh, you can see what GCC actually does by invoking GCC. We may note, however, that the resulting LD or collect2 command may differ depending on how your GCC was configured. Many may differ based on the OX or may differ depending on which libc is being used. Let's just compile the hello world. No, some no, not some dot C into some linker found a problem. Let's see, and he said that I can use the V flag to see what things happen. Okay. Now if I add with this another file that I want to link with it, how does that happen? Yo, um, yeah, hmm, hmm, how does that happen? Some dot C E and then some dot S. Let's see. Huh. Ah, okay, S function here. It is working. Okay, so it linked the C file and our assembly code. Some.c. I passed in 5 and 10. C. If I pass in like a 100, that is implicit conversion from unsigned to in. That is quite a bit big number. I should see 110. And what do I see? 100 and 10. So it is working. I am able to call assembly functions from my C program. Now multiply two numbers and subtract two numbers. Should be easy. Um, make a new file named mul.s and global multiplier share. That is crazy. Multiplier as key align at the boundary of 2 to make our program faster. And then in the text section, we will have the multiplier function, which stores the operation, the thing in the zeroth address after multiplying what the contents of the first address of the first and the zeroth address. Let's go back to some C function and we will call the multiplier here. Let's declare that there is a function called multiplier which takes in two inputs A and B and then some value and mul values, no, not values, value, and then multiply. It will take in, let's say, 12 multiplied by 40, which should result in 480, and then printf the result here. Uh, mul value. Okay, now GCC sum dot C sum dot S and mul dot S, and the output should be final. Okay, now there is a problem. Multiplier reference from main in sum dot O. Yep, that is 10 multiplier. I guess maybe the spelling might be wrong. Sum dot C multiplier. Okay, and what is the spelling in mul dot S? Multiplier, multiplier, multiplier. The spelling seems to be correct. spelling seems to be pretty much correct. Yep, seems to be correct. What is the problem here? Unidentified symbol for architecture ARM64. Okay, multiplier referenced from main this LD symbol not found for architecture ARM64. Okay, it is unable to find that. Why? What is what is it that I'm doing in the sum.s function that I'm not doing in the multiplier? Shit. This is small underscore. Okay, mul.s mul.s. Now GCV should work. Yay. What should be the answer? 480. And we get 10 for the summation and 480 for the other thing. And now and some nope sub.s. So global underscore subtractor IGN align at every fourth bit 2 to power 2, which is 4. And then in the text section, we are going to write store the subtraction in the zeroth register, and the operands are 0th register and the first register, and then just return and go to the sum.c thing, and we should stop calling that sum anymore. Sub subtractor, which takes in two inputs A and input B, and sub value is subtractor, and we will be subtracting from 1 2 3 4 the value 2 3 4. It should give us 1000, and then print the digit here with the sub value, right? And then gcc this shit sub.s, and okay, we got an error. I guess the spelling of subtractor differs in both the things. Oh, I didn't even like tell that there is a thing called subtractor. Subtractor this. Let's see if the spelling is correct. Yep, spelling seems to be same. And GCC this shit and call the final thing. And we should get 1000 as subtraction. Okay, we did these three things, but still we are calling it from a C function, and we are passing it in inputs from a C function, and we are handling the output to be printed on the screen using a C function. Now, swap two values. Of two registers without using a third register. That is doable actually. Yep. Uh, we have to take, what is it? XOR or NOR? I guess XOR. Um, Bitwise XOR of both the things. We can do it using a bitwise operation or using some add and subtract thing. Let's do add and subtract thing. But then how can I return two integers? And how can I declare a function in C that returns two integers? ChatGPT this shit. How to declare a function in C that returns two integers that returns two integers. Let's see. Using a struct. You can define a struct to hold two integers and return that struct. Okay, two integers, type def. Okay, this thing is struct, and then this is how you define a structure, and then type def is whatever comes, whatever thing is here, whatever data type is here, should be named this, right? So type def the structure this into two integers. Now this function takes nothing apparently, and then it declares a variable result which is of the type two integers, and result.a becomes 10 and result.b becomes 20 and returns the result using pointers. Pointers seem to be the correct way. I don't know how I am calling a assembly function from a C function. How can I return two values to the C function? Let's see, returning two values from assembly code into C function can be achieved using several approaches depending on how the assembly function is written and the conventions of calling environment. Since you are working on ARM64 architecture, the procedure call is standard for ARM64 bits is APCS defines how values are passed between functions. Return values in registers. For ARM64, the first few values are typically stored in the register 0, 1, etc. till register number 7. You can return two values and using register number 0 and 1. Move 10 into this and 20 into the second register. Okay, corresponding C code void extern void doesn't return anything. Okay, and takes in two things, yo, and moves value this and this. Okay, takes in two things. We have two integers a and b. It passes in the addresses of that. Okay, and then we printf these two things using a struct. Okay, wait. Int a and b are two variables which right now have not been initialized. They are in the, as I said before, they are in the dot bss section of the memory, right? And we are passing their addresses. This is used to pass in the address of the variable to the right. So 0 here has the address for A, and 1 here has the address for B. Okay, but then we are moving, we are not storing the values into 10 into the memory location of whose address is stored in these registers. We are storing these values, moving these values directly into the register. Let's see if it works or not. And return 2.s, 2.s dot global, turn 2 dot a line to and dot text return to which has move into register 0 the value 1 0 move into register 1 the value 35 somehow and then just return. That is right. That is what they say. Save this and go to some C file and define return to which takes two shit. Where is it? Two pointers, two integer pointers, A and B, and we call it here. We define two integers A and B here, and then we call the return to function over at passing the address of A and then passing in the address of B, but it does not return anything. It returns void. So we have to tell that it returns void, and then we have to printf two things: the value of A and then the value of B with the new line character A comma B. I don't know, that might just work. Return 2.s. Let's funktioniert and let's see what we get. We have some strange value. Okay, the fact that we are getting the same value every time must mean something. If I compile it again and then run, do I get the same value? Yep, I do get the same value. Something is going on with this thing here because these are not the functions that I'm writing in the return to thing. I'm not. I'm writing number 10 and number 35. I think I should do load. Wait, before loading it to the memory, I have to write the two values into some register and then load into load the value that is in the second register into the address that is stored in the 0th register and then load the value that is in the third register into the address that is stored at the first register and then what do I do? And then I return. Let's see. And now the same thing. Okay. So there seems to be a problem. If I pass in the addresses of these two. Yeah, right. Right. I pass in the addresses of these two variables right here. And then I take the value a number 10, move it to the second register, take a number 35 and move it to the third register. And then I load the value in the second register into the address that is stored in the hell. It is str store. Yes. Might just work this time. 0 and 30. Why is it 0? Why is one m 0? Dot c v and return to this. It is supposed to be 10. Okay. Move the value at register 0 into that. Why is it not 10? Let's use 1, 2, 3, 4. Is that too big? Might be, I don't know. And then no, it should not be. Compile it again. Dot final. We see 0 for A and 35 for B. Okay, we are getting somewhere. Hmm. Hmm. Am I now passing in the address to this register properly? I'm defining two integers A and B and then passing the addresses for A and B into the function this, and the first address will be at the 0th memory location and the second address will be at the first memory location, and then I am storing these values there. Or do I change this? Will I get 10 for this? That's like final. I do get B is working fine, just fine. What is the problem with the other one? What is the problem with A? Am I unable to store some value at the memory location whose address is stored in the 0th register? Why am I facing this value, this error? Is it because of what is stored at the 0th register? Let's see. Dot slash final. What do I get? I get the value there. Okay, so register 2, 3 working properly, and I am getting the input in the 0th register and in the first register. And what is the problem there? Yet I am calling the function properly. Let me remove all the other things. Okay, I declare a function which returns a void, doesn't return anything, and then that function takes in two inputs, and both are pointers to some integer in the memory. Okay, and then I declare two variables that will store some integer value, and then I pass in the address for those two variables to the function, and then I call the value, yes, and digit for A, digit for B. That should, this seems like correct here. And then I am doing the same thing here. Let's do some magic. Take in a third integer, pass that in as the third thing, and pass in the address for that, and also print that to the screen, and make the appropriate changes here. Move the value, let's say 54 into that register, and the value in the 0th register, the value in store. This seems like the correct. Is this the correct syntax for storing? overlapping, some overlapping there. Let's go to the seventh register, sixth, and the fifth. Seventh, seventh, sixth, fifth. I am only getting the correct output for the last store operation. Is that correct? Okay. Uh, okay. Um, Moved that below. The last one is okay. Okay, now it works. Why is that happening? Okay, so when I was storing, hmm, 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 what does this mean? When I start storing the value from the lowest address moving up, then I get error. And not error, but when I store a higher value, the lower value that I stored earlier becomes 0. Okay, but if I start storing from the address that is higher in the memory, moving down to the lower addresses, then there is no problem. Okay, when sto when I storing values in the memory where starting at the memory location with the least address, then as I store a value uh, store a value at a higher address, the value at the lower address becomes 0. But if I start storing values from the higher addresses, then there is no problem. Why is that? Let's see. And we are streaming. Shit, there is a lag even in my OBS. Mm, Jordan Peterson, always there, the GOAT. What's it? Okay, let's see. The behavior you are observing is likely due to overlapping memory writes caused by using word size 32-bit or double word size. An integer is 32-bit. Okay, stores instruction while stores store instruction while writing values that might be incorrectly aligned or overlapping. Yeah, that might be it. Little Indian, little Indian or high big Indian values. How is it stored? Okay, let's read this and then go to Excalibur. ARM64 registers, XN registers are 64-bit. XN registers are 64-bit. Okay. Ah, fucking hell. So I'm storing a 64-bit value. Okay, the size of an integer. What is the size of an integer? In C, 32-bit. Um, what is the size? Just tell me the size. Okay, some P printf yes, B backslash n size of int. Ah, int, but the argument has type unsigned long. Uh, uh, zoo, oh, unsigned long. Okay, we see this shit, and then final. We get four bytes, 32 bits. Okay, okay, okay. WN address stores 32 bits. Okay, if you use store to store 64-bit bits, this, and this, but the memory address you provide are too close together, example overlapping by 4 bytes, the stir instruction will overwrite adjacent memory locations, effectively zeroing out previous values. That is crazy. Why it happens? Low address to high address. If you store a 64-bit value at a lower address, example this first, it overwrites 8 bytes of memory, including parts of the memory reserved for higher addresses. Right, that makes sense. And I think it is a small endian. That is why it starts storing the number at the address that I provide moving backwards. Okay, high address to low address. When you store values starting at high addresses, subsequent writes do not overwrite the memory you have already written to because they don't overlap in memory. That does not make a lot of sense. This, this, and this. Yes, okay. If you store this, it writes 8 bytes from this, from 0 to 7. Then if you write then if you write store 6 to the address one, it writes 8 bytes from x8 to 15, overwriting part of the memory occupied by the value previously stored in this. Okay, how to avoid it? Right, writes 8 bytes, overriding the part of the memory occupied by the previous value written by star 7. But no, that did not override it. How to avoid it? Ensure proper addressing alignment. Make sure that the memory locations you are writing to this 0, 1, 2 are spaced apart properly. Use at least 8 bytes for 16-bit storing. So if I were to use instead of this, but W to store 32-bit things and store W, right? That is the thing, right? Um, if I want to store only 4 bytes, how was it? If I want to store only 4 bytes of memory, 4 bytes of value into the memory, how does that work? Macros shift. Yep, store frame pointer and stuff. P state, immediate values, register addressing. We will be reading this again. Yeah, store this into this. What are the options? If this is the syntax for either store or load, B unsigned byte, single byte, a single word, SW, yeah, STR, SW, single word, yay, STR, SW, SW, STR, SW to store a single word. And now, even if let's first see if this works like this. Okay, is it not the thing in for Mac OS somehow? The function does not work for Mac OS. The instruction, shit, even though it is ARC AArch64 final, this is working in that way. Now, and this is working when the order is like this. What if I return the order, um, change the order, and then run it? It's working because now I'm using only Harvard and I am not overriding any memories. Well, that makes sense and clears quite a few things. Now, what you can do, you can take in multiple inputs and provide multiple outputs. Now, swap two numbers. I got this. And return two. That will take two numbers. Uh, so the address 0 and the memory address the memory address at the 0 register will have some value, and the memory address at the first register will have some value. Now I want to store load LDR into the 6th register, the value that is stored at the memory address whose at the memory location whose address is stored in the 0th register, and load the value using only half a register. The value this, and now some dot C. This should effectively switch fix stuff. But now I also have to initialize the values. A is 5, right? You can see that A is 5, and we see that B is 10. That A is 5 and B is 10. Okay, now A is 5 and B is 10. Okay, I don't want to print this, and let's see what will be printed. We have A as 5 and B as 10. That is what we inputted, and now A is 10 and B is 5, effectively swapping two numbers in data movement. Now, store and load. Create a program that stores a value in memory and then retrieves it back into a register. Retrieves it back into a register. Retrieves it back into a register. That is what we are doing, is storing and loading. But is there a way through which we can read a file? That will come later. Uh, Find the maximum of two numbers. Write a program that compares two integers and outputs the larger number. That we can do using subtract. Using subtract. But then I have to output the larger number conditionally. Okay, and max dot s dot global max finder dot align at 4 bytes dot text, and max finder. First of all, I will no, this time I do not have to work with pointers because I am outputting only one value. So Ray, I guess. Now, how can I compare two numbers and then return the one that is maximum? Oh, what does the CMP function compare? M MP instruction in ARM 64. Immediate. What is the difference between these two? Oh, general instruction. Okay. So sub s immediate. Okay. Alias compare immediate. Wait. Okay. It takes in a register number, other register number, or an immediate value, and something. An unsigned immediate in the range this. You can provide this stack pointer or some register number, 32-bit general register, a register and an immediate value. Okay, a register and an immediate value is the optional left shift to apply to the immediate value, defaulting to LSL00 left shift. Uses compare immediate subtracts an optionally shifted immediate value from a register value. It updates the condition flag based on the result and discards the result. Okay. Uh, Condition flag. Now I have to see about branching. I have the values in register 0 and register 1. What is going to be my algorithm for finding it out? Again, minus subtract, right? And then if it is negative, okay, let me write two functions. First big, okay, it will, what will this do? First big will just return because the first value is already in the first. register, zeroth register, that is the first register. And then the second when the second number is big, then it will move into the zeroth register the value that is in the first register and then return. Okay, now I do compare the value at the zeroth register and the value at the first register minus. If this is negative, now I want to use a branch instruction. If this is negative, I think this is the correct thing. If this is negative, which means that the second one is big, then second is big, then it will return. And if it is not, then just first big. Now, this might be a stupid thing, but I think this will work. This might just work. Okay. So return an integer, max finder, int a, comma, int b, and this will not take any addresses, it will take the numbers themselves. Int max equal max finder, and then yay, I want to output the thing, max thingy, max. Now let's test our stupid hypothesis, and that is wrong. Max finder main, max finder, okay, max dot s, max finder, max finder, max finder, max finder takes in two numbers and returns one number. What is the error? Max finder reference from this symbol is not found in the architecture. Okay. Find. The spelling is correct. Oh, my bad. Max dot is BN second big. Did you mean BL? Okay. Uh, add GPT. How to branch in assembly. Wait, wait. I had that in the book. Wait, let me go to washroom for a minute. Yep, I'm back. Right back. Here we are. Okay. Uh, yeah. Um, okay. You're looking about branch. How to branch based on based on the flag. How can I branch based on the flag? What are the different flags for branching? Where was it? Where was it? Where was the table for branching? Yep, here. Equal, not equal. Yep, I know equal, not equal. Saying greater than binary encoding is this. I want the result is 0 to be 0, and I want negative, meaning negative to be 1. I want 1 0 0 0 0. Is that correct? 1 0 0 0 1 0 0 0. This is for unsigned higher, which means that carry is 1. No, I want to be 1 and everything else to be 0. I want negative to be 1 and equal to 1 minus mi plus, okay, negative is the second one, bmi and max. So, and I, let's see if this works. GCC and we have an error. B and I doesn't mean anything. BIC, okay, chat GPT. How, uh, what? How to branch based on the flag at P state in AArch64 Mac. Let's see, in Arch Assembly 64, like M1 Mac, the P state processor state register contains flags that influence control flow. These flags include the condition flow, negative, 0, carry, overflow. These flags are updated by many instructions such as compare. Yeah, compare is the one that I'm using. A branch and then condition. B and then condition. CBZ, branch if it is 0, branch if a register is 0 or non-zero. C, test a specific bit in a register and branch. T for test, compare bit 0. Okay, this compare two numbers, update NZCV flags. Okay, here is how this dot, I have to use dot. Okay, and max dot s dot dot ni invalid condition code y ni not 0, uh, negative mi and gcc. It works, and now maximum number seems to be 10. And let's see. So I change the C program to make this the maximum. Let's see, now compile and now run it, and we get 50 as the maximum number. S funktioniert and max dot s. Okay, what I'm doing is doing this and updating the flag. This function, this instruction updates the flag, and then if there is negative flag is on, then I see that the second number is big. So I branch to the instructions under the second big label. And if not, then this will not work, and I will just branch to the first big label, which just returns. And I don't even have to do that. I can just return here directly. Okay. What are the other things I can check? I can check for equality if they are equal or not. That is not what I want to check. If less than n is not equal to v somehow. N is not equal to v. Uh, n is not equal to v. What does it mean? N is not equal to v. If v is 1, then it is not, it is overflow. And let's use LT to see how that works. Now we can compare functions, it seems. Now, store and load, control flow, find the maximum of two numbers, loop to add. Create a loop that adds numbers from 1 to 10 and stores the result in a register. Wait, not just 1 to 10. I will take a number from the C program and add the results. Okay, and loop adder dot x global loop adder dot align at 2, and then in the text section in the loop adder label, do this. Now I want to create a loop which will add whatever is the value in the register 0 and in the register 1, and the loop will then check, and then yep, yeah, it will compare the value in register 1 with the value 0, and it will branch if they are equal. Equal is EQ. What is the thing for not equal? Shit. Yo, Technoblade. What is the code for not equal? Equal is EQ. Now, what is the code for not equal? Yeah, equal, not equal, and E, not equal. EQ equal. Okay. If they are not equal, then branch to the loop, or BL. Yes, because I want to come back here. And before that, I have to subtract the value in register 1 by 1. Hmm, this should work. Well, now first I have to call it BL, call it. Wow. But I have to know what I have to lose. Just call it. Okay. I will get the number in the 0th register. So first I have to move into the first register, the number that I got in the 0th register, and then I have to move into the 0th register. What value? The value 0 itself, and then return here. With some C function, int, what is the name? Loop adder. It returns an integer and takes in a single integer n. And let's do this. Int sum equals loop adder, and the number I want to give in is like 10, let's say. And then say that the sum is this number sum GCC. I want to GCC this shit sum.c and loop adder.s, and the output will be the final thing, the last thing we ever do, final. And we get in segmentation fault. Okay, you get a segmentation fault. Spreading my wings too much. Mm, why am I getting a segmentation fault here? Moves the value into the first register. The number n that we got has the first input, and then moves the value 0 into 0, and then false the thing. Maybe I can just do this here. Think this should work. Hmm. GCC this shit. And final, we get the sum as 55. It's funktioniert jetzt. And we can update our sum.c to be 100. Let's see the sum now. Yay. Is that it? Yeah, it seems to be it. How to avoid it? No. Now, control flow loop to add numbers. Okay, even or odd. Write a program to check if an integer given is even or odd. Bitwise using bitwise operation. Well, if the last bit is 1, then it is odd. If the last bit is 0, then it is even. So I have to take a return the last bit. Uh, okay. Okay. How to do um uh, bitwise instructions in AArch64 assembly. Uh, bitwise and shifted register. Bitwise and with an immediate value. Yo, just and why is this the language here? operand 1 and operand second. Okay, um, how to a single bit from a register to work with. I only want the last bit. Selecting a single bit from a register involves using bitwise operations, step-by-step operation. Okay, in ARM64 13 64-bit register when I use X and 1-bit register when I use W. Move into register 0. This oh, and the thing that is in the second register and in the first register. And mask isolates the third bit of 2. Of this into if third bit in X is 1. In I, otherwise X1 will be 0. Shift the bit to the position 0. Okay, load the bit position. Okay, and the bit that I want is, let's say, third. So I move that number into the 0th register, and then I want the singular bit to go into register 1 here. And then I left shift, left the amount and the value in the second register, the amount of times that is in the 0th register. Left shift this A R right shift by 3 positions makes more sense than shifting it to left. Mask to keep only the LSB isolated bit value. Take the AND operation off. This and one. I only want the first bit. So this line gets the bit that I want at the first position. And now if I take its AND with 1, I will get the answer. I will return. Okay, okay. And even or dot s dot global even or not or dot line 2 and then dot text with even odd and the number that I want will be in the 0th register. Now if I just and store the value in the 0th register, okay, what does this do? The 0th, it is saying and the value, find the bitwise and of the value stored in the 0th register with 1. So 1 in binary is 00001. And if I find the AND, bitwise AND of that value with the value that is at the 0th register, then every other bit will become 0. And only the first bit, the least significant bit, is the one that determines if the number is even or odd. If that bit is 0, then I will get 0 in the 0th register. But if that bit is 1, then 1 and 1 will return 1 in the 0th register. And that is what I will return. Now wait, if it is 0, Then I want, so I should take a knot. Is that even possible? Knot of this into this, and then return. Okay. Now, if it is even, then uh, I will get 0 in the zeroth register. And if it is odd, then I will get 1 in the odd register. But I want to return 1 when it is even and 0 when it is odd. Therefore, I take a knot of it and I will set this is a bitwise knot. This is a bitwise knot. Okay, let's see how it works. Some uh, this will return an integer, even, odd, take in an integer, and even odd. Let's see if this works. Even odd dot s. Ah, invalid operation for instruction. Do not how to do anything. Resist the attention economy. How to do not instruction on AArch64. Uh, nope. The instruction does nothing. Do logical not. Logical not. BIC. Inverts all bits. Ah, BIC bit clear instruction, which is easily inverts all bit of the register, essentially acting as a not. I do not want to invert all the bits. Oh, is this specifying the bits that I want to invert? Or I can just do, how long? This should be 8. 1 byte is represented by 2 hex characters, and I am using 8 bytes. So these should be 16 hex characters. 7, 8, yep. So I only want to invert the first byte. Even odd. What was it? Boy, Bank of India BIC. BIC, I want to store in this the result of this. And what do I want? 0, 0, 2 bytes, 3 bytes, 4 bytes, 5 bytes, 6 bytes, 7 bytes. Yeah, this should work. Well, I should tell them that this is a hex number. Es funktioniert. Final. Sum is 0. No. Sum.c, sum takes in 100. 0. That is not good. Is even. Even is even, and let's say it takes the value 1. What does it do now? Is it returning 0? I changed it. Uh, by some dots. C. Well, this is not going to have any logical difference, but pleasing is even and even or dot s. What if I do not do this? So we are working with what if things now. If I do not do this, then I don't get anything. That is sense making. I take in 101, which is something in binary. And then I take its and with number 1, which performs the AND operation and stores the result in 0. And specify a specific bit mask for the fifth bit. Mhm. Shift to position 0, taking and mask to keep only the LSB isolated bit. Ah, hmm, hmm, hmm. This should work. This should work. The number there is 101. Compile again. It's even. Fine. I have to now flip on some dot C. Even odd. I want to flip this number. Okay, it is not even now. But if it is, what if it is? Now compile. It should give us is even arrow 1. Well, the first thing you do when you get an error is you recompile and run it again. The error still exists. Some dot C. It is 0. Compile it with an opposite value. So the error is in the assembly. This ain't functioning. How can I flip a single bit? This is these are very stupid questions because these are very, very specific questions. I should be able, I should be asking like general questions to get a knowledge, understanding of how it works generally. Code for the fourth bit. Flip the fourth bit. Bit position 0. Corresponds to fourth bit. Bit position third. XOR operation. 1 becomes 0 and 0 becomes 1. That is not the XOR operation. But still, that's oh. The XOR operation that you are taking off this with this, that results in something like this. Okay. Okay. Prepare a mask. Uh, Create a mask with a 1 at the weight position you want to flip. This is represented by this in binary, it seems. Hmm. What is 1 and 4 zeros? No, 3 zeros. What is 1 and 3 zeros? That is seems to be 8. Yes, that seems to be 8, and 8 should be 8. Hmm, 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 hmm. 8 is not 8ing here. Okay. Hmm, 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 hmm. Bit flip using an immediate index. Oh, I want to flip the bit of the bit, the value this fourth bit of x2, and I'm using 3 here. 1 is already there. If I move it one time, then I get the second bit. And XOR 1 should work. Let's see. XOR on the register this. Save the result in 0th register, and the operand is in the first register. And do this GCC event, and okay. It is not XOR, it is EOR somehow. It is EO O O EOR, and do the GCC thing and final, and it's even. I think it was 101 there. Yep, 101. Now the answer should be even. What gets printed to the screen is should be even, is even. One is function yet. Okay, how long has it been? 2 hours, 80 minutes. Okay, 18 minutes, not 80. 80 would be uh, bitwise operations. Okay, array manipulation. What is the last thing? Advanced. Factorial of a number. Fibonacci. GCD. Okay, we can do factorial actually. We can actually do factorial. In factorial dot factorial line 2, and in the text thing factorial label will store the address for the instructions. This now I would need a loop. First of all, I will start by moving the value into the register 1, the value that is in the register 0, and then moving into register 1, the value 1. Now I can every time multiply what is in the register 1 and then subtract 1, and then see if the things that is remaining in the first register, if it is 0, then I return, and if it is not 0, no, if it is 1, I can return, because I do not have to multiply 1 and then subtract and get to down to 0. If it is 1, I can just return. Now I will call the function here. B what loop. Okay, and I will define the loop thing here. Now, loop thing, what it will do, it will multiply, store the result in the zeroth register, and it will multiply the contents of the zeroth register and the contents of the first register, and then it will subtract from the first, subtract and store the value in the first register. It will subtract from the first register the value 1, and then it will compare the contents of the first register with 1, and if BE not equal, and if they are not equal, then it will loop, and if not, then just return some dot C. It will return a factorial. It is called factorial. Take in a number, factorial fact, is it, it is called of uh, factorial fact GCC, and instead of this I want factorial.s to be stored in the final. I think there is a very big number whose factorial we are finding. Factorial is 0. Hmm. Hmm. Some dot C, shit. Factorial of 100. I think it overflowed. Let's go till 5. What is the factorial of 5? 5 into 4, 20, 20 into 3 into 6, 3 into 2, 6 into 21, 20. We should get 120 out of this. Let's see the upper limit. 20 cc final. Yes, we have reached the upper limit at 20. Some dot C, because well, 20 is supposed to have like more than 10 zeros, which is a very long number. Number having 10 zeros is a very long number. Now GCC this, and let's see if it works for 10. It does work for 10. Now let's see how far ahead we can go. Change this to 13, or maybe like 15 binary search. Yeah, final, and yes, still functioning. Some dot C. Let's go there, and 7. I think this will overflow. This, yeah, it did overflow, and let's go and change it to 16. 16. I don't know. I guess this will work fine. Yep, it did work fine. And 17. Will 17 overflow? I think it did not work fine because the difference between this and this, what is the difference between this and this? 200, okay, and then 1, 2, 3, 4, 5, 6, 7 digits here after 200. 1, 2, 3, 4, 5, 6, 7 digits here. So it did overflow. It did overflow. Okay, so now we did the factorial function also. And now we can compile, we can write assembly, and we can call assembly functions from the C language. And I guess now is the time that we can begin reading this chapter again from the start, from tomorrow, because now we can just, whatever we read here, we can go back and write the code for the same. And that was becoming a problem, because just reading something and not getting your hands dirty with it is not a good way for learning. It is just Reading this like a novel is has much more to do with memory than with understanding. So now we can just test whatever we read. And thank you. Today's stream was much longer